third type of material I want to talk about is wood. So if wood is an option, it comes with few aspects that makes it easy to work with. The most common wood species, wood is natural, it comes from trees. So there are wood species that are good for construction. It's typically used soft wood. They can be nailed and connections can be applied to them easily. Other type of wood is called hardwood. These wood species are much stronger but difficult to work with on a construction basis. So they are maybe good for furniture or for fancy, nice finishes and flooring. But for construction, the main types are like fir, like Douglas fir, spruce, cedar, pine. These are all a good species, and they get graded, usually visually graded, and they can be also tested to provide their strength. So usually the fir, the Douglas fir, has like the highest strength. If you're building like a multi-story building, you will probably need the ground floor to have like some sort of fir, Douglas fir part of it. But I've used these different species and they have different strength, and this absolutely needs to be taken into account. So what are the options, the sections, the shapes that we can work with wood? There is engineered wood. Engineered wood is made out of the saw cut wood, like it comes into like rectangular boards of wood, and those can be used in construction for like something like this, to build the walls, to build the ceiling. And engineered wood can come as like different products. So the first product I want to talk about is plywood or fiber boards. It's made out of layers, pieces of wood with very high pressure and glued together to create sheets. So this can create like the sheathing, the outside of a wall or the top side of a floor using plywood or fiber boards. Glulam is another engineered section. This is an example here. I personally love how they look. You can create deeper sections than what you normally get from like one tree. So you can put these pieces of wood under pressure with glue, hence the name laminated glued pieces of wood, glulam. And you can introduce these curves and they usually look great. There's also eye joists. The top side and the bottom side is like solid wood, and the web is probably made out of like some engineered wood. They're very effective. And the last type of engineered wood is trusses. So you can get these built on the ground and then you kind of lift them to create all sorts of roofs and larger spans and resist the loads on them. Connections will need nails, correct length, correct diameter. You will also sometimes resort to these metal connections. This is an example of a column to beam connection with like a saddle, and the number of nails on the side is checked and calculated based on the loads and stresses. This is a very interesting feature. I always had to go and check for a tie or an element like this. The main function is to hold the roof to the rest of the structure. This is, I guess, a disadvantage of wood being like on the light side. The structures made of wood are usually lighter than other construction materials. So in a case of very high wind speeds, like a hurricane or a storm, there is usually suction, upward uplift due to wind. Very high wind speeds create suction action on the roof. And you can look up these on videos. There's all sorts of videos how a storm can pick up the roof and cut it like clean off the rest of the building. So details like this, specifying that little connection here can significantly help the roof stay in place under very high wind speeds. All right, this is the fourth type of material, which is masonry. I mentioned it is almost like building with Lego. A lot of builders like working with it because you can gradually build the wall, skip the heavy cranes to move like precast, or all the labor-intensive form works for cast in place, and you can still get fairly good resistance, a bearing resistance out of it, especially if you start filling these cores. Like for example, these are the units, they have voids in them, and you can fill them with concrete if needed. That will increase the strength of the wall. And if you need to reinforce it, you can start introducing rebar. So it's reinforced masonry. I just want to mention that masonry is sensitive also to the workmanship of the building. So obviously the builders, they will need to pay good attention to the joints and the alignments, not too much eccentricity on the wall, and hence this is also taking into the design these safety factors. This is an example of how you can build structural elements like beams and columns within a given wall. This will give a clear path for the load and reinforce openings. So for example, this is a window, and typically it would need like a lintel or a beam above it, and introducing these reinforced columns or grouted voids around it will reinforce the opening against like any cracks that might kind of result at this weak spot in the wall. So the unit that can be used to create the beams, it has a U shape. So you can place reinforcement at the bottom and then pour concrete in the void, and the structural engineer can calculate the capacity and the resistance of this masonry beam, and the same concept can be done for columns. So for example, 4 units here are filled, grouted with bars and even these ties to strengthen and confine the masonry units against compression and axial load. A very common system, I see it a lot, it combines the relative ease of masonry walls with the quick and fast precast hollow core systems. So it's slabs made out of precast hollow core on top of masonry walls. So the multi-story building can go relatively high, not as high as reinforced concrete with like high strength, and relatively quickly. So you can see here, this is the masonry, these are hollow cores, and you will need the crane. You can see the chains, and all what you have to do is like put the hollow core, start building the next floor walls, and then detail the connection to leave bearing spaces for the hollow core, and then repeat the cycle. So the floors can go up relatively quick.